Welcome back. We're going to talk now about the synthesis of ethers via the acid-catalyzed alcohol condensation. And as the name implies, we will start with alcohols, but what we're going to do is, upon addition of acid, we're going to make that alcohol react with another equivalent of alcohol in order to form an ether. And let's see how this works out. If you start with your alcohol and you do add acid, the alcohol is going to attack that proton, and if this was HCl, then you will produce chloride. If this was HBr, you'll produce bromide, right? But the point is that you will have an H plus that your alcohol will be attacking. This will produce protonated alcohol, which now has an oxonium cation present. And what that basically does is it creates an electrophilic carbon over here. And not only that, but you currently possess a pretty good leaving group. Protonated alcohol is the same thing as water leaving group, and that's a pretty good leaving group. So the moment this happens, the second alcohol can then attack this electrophilic carbon and kick out water. And you end up generating a protonated ether simply because the alcohol comes along with its own hydrogen, right? So that hydrogen still needs to be there, but now you have 3 bonds around the oxygen, which makes the oxygen positively charged. So the last thing is that the water molecule or maybe an alcohol molecule comes in and attacks that protonated ether, which then has electrons go towards that oxonium cation, producing now a neutral ether, and your acid gets reformed. So this is technically a catalytic process, and you don't need much than a few drops of acid to make this happen. But there's one more thing that needs to be mentioned, and that is the case that each one of these steps is actually in equilibrium with each other. So this is actually a reversible reaction. And what that implies is that if you do start entirely with alcohol and you add your acid to it, you will end up forming an ether. However, if you start with an ether, so like if that's your solvent and then you happen to add acid to it, what's going to happen is that you're going to end up destroying the ether and forming alcohol. And this is one of the reasons why you can't really add hydrobromic acid, HBr, to ether, because the ether will definitely break apart into alcohol and alkyl bromide. So they're incompatible with each other. But you can actually add, a fair amount, like 0.5 molar solutions, maybe even 1 molar solutions of HCl into ethers, and they tend to be relatively stable. But the stronger the acid is, the more likely you are to make your ether undergo the backwards reactions all the way back to the alcohol. So that's just something to keep in mind. All right, so you have good leaving groups on both directions. In the case of forming the ether, you had your water leaving group, right? In the case of forming your alcohol, well, you have your protonated alcohol leaving group present, right? So those are the main regions or reasons associated with this. So the other thing about it too is that this is really only going to work well via alcohols that are primary or methyl, because technically what's happening here is that you're undergoing not an SN1 reaction, but rather an SN2 reaction. And it's not the best SN2 reaction to have anyway, because you're using protic solvents. The solution is acidic. So condition wise, this is not the best conditions for SN2. So this is not the greatest, and you're also constrained to your alcohols being methyl or primary alcohols. The second thing too is that if you do use secondary or tertiary, rearrangements may happen, and worse, you may even undergo E1 reactions. And the other thing too is that, practically speaking, if you try to do this reaction, it will only be good if you're trying to put the same 2 alkyl groups onto this oxygen. So you cannot have R and R prime be different things anymore. These two things will end up being the same because you're using the same alcohol to enact the process. So those are the restrictions associated with this type of reaction. So for instance, if you were to start with this alcohol and you add some acid to it and want to find out what kind of ether we will produce, Well, the process will start by having your alcohol, which happens to be primary, right? That's actually important to notice, primary alcohol. The alcohol will be protonated with your acid. You'll produce you produce pretty much water as your leaving group. So this molecule with your electrophilic carbon present will be attacked by a second molecule of that very alcohol, kicking off your water leaving group and producing your protonated ether. And once more, that hydrogen is present there because it came from this alcohol that already had a hydrogen bound to it. But then that needs to come off to give you a neutral product. So your water will attack that proton, the electrons will be kicked off towards the ether oxygen, and that will produce your final product as well as reform your acid, which is the catalyst in this reaction. So that will be the final product that you will end up making the reaction. Okay, so that's it for this particular type of reaction. In the next one, we're going to talk about a very specific addendum to the ether chapter, which is the discussion of crown ethers. And they're interesting molecules to say the least. So I'll save that for the next video. So see you then.